Okay, testing, 1, 2. Oh, magic. Okay, much better camera here today. I'm using my iPhone as a webcam. Amazing. So this is an update for OpenLander. I've got a cool new neural network trained, same structure network, huge data set. This is about 8 terabytes of data and much larger batch sizes thanks to some help from NVIDIA with some great big graphics cards. So it's another demo of how this has progressed basically. So I have the same setup as usual, but I can actually show it a lot better this time. So I have one of these cool little Luxonis Oak One light cameras, super cheap. These are $100. They have the cheapest sensor from Luxonis in there. It's a tiny little ball with a Myriad X processor, extremely cheap, extremely lightweight. And it's pointed at my screen, as you can see on my MacBook, rigged together with some bits of grip. And so this is obviously not a fantastic setup in terms of image quality, because the camera is, you can kind of see it there in the top right, the camera is trying to focus constantly on the screen, so the focus is a little off. And there's some moire, just interference between the resolution of the camera and the screen itself. So actually, I've deactivated autofocus, so it's not actually trying to focus right now. I've locked the focus slightly behind the screen, so everything is a little out of focus, which is better for the neural network because it's trained to not need perfect focus in the training data. And it deals adequately with bad focus. Better than it deals with the interference pattern, the little squares. It doesn't like that at all. Just to give you another look at one of these boards, this is what the neural network is deployed to. So it's actually running on one of these chips. So it's absolutely tiny. As you can see, this has a sensor on the front, and actually the one that's running on right now is a slightly cheaper sensor, but basically the same kind of thing. And on the back it has Intel Myriad X TPU. So as you can see, it's absolutely tiny, and the neural network is actually deployed to this device. So you can put one of these on your drone. It's 15 grams, so it's virtually weightless. Runs on 5 volts. You just connect it to whatever host, ARM32 or ARM64 or whatever's running your drone, and you can deploy these AI capabilities directly to it. And so this neural network, the cool update here is that it's trained on much larger batch sizes, because I had access to a lot more VRAM than what I usually have on my devices that I have here in my office. So it's better generalized. It converges to a lower result in the loss function, basically. Well, I guess not technically lower because it's larger batch sizes, but just generalizes better. Basically, all that means is you get better performance and probably more stable performance when you're using it, meaning more stable, like frame to frame inside what you're doing. So to give a demo of this, I have a bunch of pictures on the screen. The camera is rigged up to point at the screen, as I showed just now, and I'm going to just pan around, zoom around, and then possibly cut around in this video so it's not too long and show what's going on. So let me skip back to the beginning of this folder. These are the same images I've been using over the last few videos to show what's going on. There's my logo. You can see, so what's going on here, just to explain, the neural network is trained on the height that you would be using a drone sort of for delivery or for landing when you're coming into land. So it's supposed to be at a height that simulates about, let's say, 6 meters to about 50 meters up. So most of these images are taken higher, and they're taken with longer telephoto lenses. So I'm going to zoom in a bit to simulate a drone coming down and then pan around inside the images. What you can see here in the top right-hand corner, this is the output from the RGB stream with the neural network mask overlaid. So the blue area is what the neural network considers safe. Once again, we're too high here, so don't regard this as a good output. So blue is where you can land. By default, the neural network is negative, so everything that's not colored is considered unsafe. It's a place you wouldn't want to go to land or to deliver a package. And then you'll see in the video later on, there are some areas that are marked yellow, and these are humans or possibly humans. The human output layer is actually extremely sensitive. I've kept it more sensitive than the rest, so it tends to go quite quickly to human. The reason for this is that this neural network, this whole system, is supposed to be a safety feature. It's not a detector, so it's not really trying to find specifically humans, like for search and rescue operations. This is really to avoid people. So the idea is that if you have a set of if you have an image and you find people, that's the area you want to avoid the most. So if it's potentially people and you're not quite sure, it's best to avoid them for safety. So let's take a look. So this image, there's not much going on. We can zoom in a little and see the neural network considers all of this safe for delivery, which is nice, or safe for landing, depending on what you're doing. So there we go. You can see it has trouble with the camera focusing on the screen. Like there are some areas of interference there that give weird results. Once again, this is more due to the setup I have here than the actual neural network. So don't consider any of this a real indication of like the final performance on a device. It works much better in real life when you actually put it on a drone, just so you know. I'll show some demos of this later in another video. Another cool thing that you can see here, this is running on this device at 18.32 frames per second right now. So with all of the rest of the processing that I'm doing, it's actually happening on the host device, so that's on my Mac right here. But the neural network itself is running at 18 frames per second. So the performance is fantastic, and actually, even with such a small device as this thing here, there's still quite a lot of overhead there of performance. If we want to make a version that's higher input resolution or things like this, or that can detect more classes of output, which actually doesn't really affect the performance all that much, there's quite a lot that can be done on this device to even improve this and run at maybe 4 or 5 frames per second or something like this, which is plenty for a real-time operation of this kind of nature. So let's look at these pictures. So here, zoom in a bit so it's closer to where we would actually be with the drone. This is kind of an interesting one. So there's some houses and the street and things going on. So you can see some of that yellow class. Sorry. So you can see there's people there on the street. These people here, if we zoom in a bit, we can see what those people are doing. This is kind of difficult to control here. Okay, so you can see there's a guy on a bike there and another guy holding his phone. Those are correctly identified as human class. So the thing you want to avoid the most. And all of the blue area here is considered safe for delivery. There are other bits that are considered potentially humans, so it would do no harm to avoid those. Like this tree here, that is an obstacle, so fantastic, we're happy to avoid it. These two black squares on the ground, the neural network doesn't like those, which is probably fine, doesn't really matter. And there you go, so you can see all of the buildings at this height, which is kind of where it's trained for, are well recognized as obstacles, and we're not trying to fly over those or deliver on them or land on them at least. And then if we move over a little bit, we can see what goes on. We can pan around the street here. There you go. As we go down this piece of street, it doesn't seem to like it. Doesn't like that. It should be safe, but it's not considering it safe. So there's still some evolution there that could be better in the future. This is kind of interesting up here. I just noticed this a second ago. This whole area here, the neural network is considering safe to land, and this does seem like it's someone's like rooftop patio there, which is kind of fun. And the neural network has identified this correctly from the terabytes of training data that's created from a synthetic pipeline that I built. It's actually considering that to be a safe landing area, which is kind of cool because that is possibly an area where you would want to land or deliver, depending on what you're up to. Could also train it to avoid that. It kind of depends on circumstances. And all that yellow area there is considered potentially humans. I guess that's because there's colored objects, there's stuff there that looks like it could be the shape of a human. And that's what the neural network has learned at this scale. So we can zoom out and pan around. As you can see, all of these houses at this kind of height are correctly identified as obstacles, and that's fantastic. That's what we're trying to get to. All right, let's look for some other pictures and see. So I haven't actually run it on most of the stuff on in this folder, so I'm not sure how it'll perform. So we'll find out together. So here we have these kind of row houses. They're all identical. The neural network is correctly identifying at this height that everything is an obstacle, which is great. because it doesn't look for tiny little areas. I didn't explain the two boxes in the bottom right down here and top left. The bottom right is showing the mask output, so everything that the neural network puts in a category is in real time in here. And the top, so this is humans and obstacles, so it doesn't actually make that much sense because you'd want to separate those. I'm just showing it like as a debug thing. And the top left one here, the selected landing spot, this has some logic applied on the mask, and it's bad logic because I'm just using it as an example to show that you can do stuff with it for people who, kind of non-technical people who are trying to figure this out. What I'm doing here actually is just taking the largest continuous area and then putting a dot in the middle and saying this is your delivery or landing spot. I can't remember whether it's in this code it has delivery or landing in there right now, but we can zoom in and see. If we find, if this identifies a safe area, maybe one of these courtyards. There you go. As we come in, these courtyards become large enough that the neural network thinks they might be safe. There we go. Once again, you have this interference pattern that's kind of messing things up, but still doing a pretty good job there. If that becomes big enough, there we go. Then there's some logic in the top left box there that says that that's a drop site. There you go, like here, for example. And so it's discarding the smaller areas and just taking the bigger one. It needs some more logic here because it's not removing humans, for example, and it's not, if there's a hole in that area, it doesn't care about it. It just like leaves it like that and puts the drop site right in the middle of the hole. So it's just to show that you can apply your own logic on top of that. But so we're getting to a resolution here where this is kind of pixel mush, so this picture is not so useful. But you can see it's correctly recognizing that the trees are obstacles, the buildings are obstacles, and these little courtyards are potentially usable, maybe. There are all these trees, we don't want those. But this is just not the kind of environment where you want to either land a drone or deliver something anyway, so it's not a fantastic example, but there you go. Now you know how it works, at least, the script. Here we go, some houses with some gardens. This is kind of the drone delivery scenario. This is kind of the environments where things are being tested right now. So if we zoom in, we have a street here. The street is landable. That truck there is not quite completely masked out. It should be done better. It does really good with cars. The cars are very well recognized as obstacles and avoided. The street is flat and safe because I consider it that way in the training data. Could remove streets completely, but doesn't really make that much sense because driveways are often the prime delivery sites or landing sites, depending on use cases. But there you go, it's well recognized. And the cool thing is, in this kind of environment, you can see that the segmentation does a really good job of finding small areas in gardens. So that's my mouse cursor, you can see moving across there. You can see here, there's a house, looks like there's some construction. And this little garden here is being mapped as a potentially safe area for delivery, which is cool. Because if you want to automate your drone coming in, and you don't want to... Or, let's say it's a delivery system and your customer has mapped the landing spot to be, as per GPS, right above this hedge here, for example, where I have the mouse cursor, which is kind of messing up the neural network. You don't want to actually deliver on that hedge, but that might be where your user has given you the tag to deliver, right? So GPS position will be there, but what you actually want to do is identify, oh look, there's a bigger area right next to this, which is safe. And if we come in here, that looks clean and big enough, and let's go in there and deliver right in the middle of that area because that's a clean, flat landing site. So deliver or land, depending on what you're up to. So that gives you a good indication of what kind of the goal is here, is to find these usable spots and automate away that aspect of users selecting locations and then having these locations potentially not actually be usable, or have them either because they're obstructed or just because the GPS coordinates don't really correspond, or someone's planted a tree or something's changed and this kind of thing. So here, for example, another little front garden. Lots of mess around the edges here, but we're correctly identifying this is the cleanest contiguous clean space. And if you were to deliver right in the middle of that, you'd be pretty safe. Once again, the logic here just takes the middle of it. You could make it a lot smarter, but you get the idea from that, right? There we go. So some more streets, stuff like that. Does a good job with streets. Little courtyard there. And if I zoom out, it's not trained for super high, but you can see it does a good enough job of understanding like where houses are for the most part, and what's the kind of stuff you'd want to avoid. But it's really meant for refining an area, like when you're coming in here, figuring out, okay, what's safe. You can see there are some interesting kind of emergent behaviors from this. It looks like this is a terrace, this white, these cobblestones here, and the neural network is correctly identifying that as safe flat space, just visually once again. So there's a commercial version of this neural network, which is I have a bigger version of the network itself, and it's trained on a little more data, and that version also works in conjunction with stereo systems. So like on one of these cameras or a bigger one of these. So you have the stereo system and you have the neural network working on RGB. The neural network can also run on a more powerful chip in that system. And the stereo gives you the basic information of how far is the surface flat, is it obstructed, are things moving about, which is also done in real time at 15 to 30 frames per second, depending on how it's running. And then on top of that, you run the RGB system, this one to figure out what's safe and what's not. But here you just see in OpenLander, it's just the RGB that's published for free, and it's a low resolution RGB, but very, very fast. So we have this 18 frames per second. But so it's interesting to see that even with just the RGB system, you can get this pretty smart behavior potentially, because you can see here we're doing a pretty good job of separating out what the clean area is, where the safe area is. So this particular garden has loads of stuff in it. So once again, like the logic in the top left here is not really what you'd want, because you can see all of this yellow stuff is considered obstacles, but it's considered human category. And in the top left here, I'm just lumping all of that together. But if you were to use it here, you could kind of avoid most of the stuff. It doesn't do a good job with that garden chair there, it seems. But if you took the center of that area, you'd still be in a good spot. Let's see. So if we fly over some of this, I'll simulate flying. As you can see, the house is segmented out, the trees are segmented out, all of this is doing a good job. And we have a little garden over here, which looks like a good landing spot. There you go. And that's where you want to land your drone. Or maybe this one over here. Once again, it's doing a pretty good job. This is trained on really, really big batches. Generalizes very, very clean. I'm quite happy with it. And it's free, so you should put it on your drone and try it out. We can do a couple more images here. I'm going to try to keep this relatively short because I need to take off. And then you can give me feedback and tell me what you want me to add to it. So once again, it's not trained for this height, but it's kind of interesting to see, like quite high up here. It's doing a good job of segmenting out those trees and the main big obstacles. And then if we come in, it's going to be much better. Like this is the kind of height it's trained at. So these buildings are segmented out. The cars are segmented out. Everything that's blue is safe to land. This is quite low resolution actually, so I'm not going to zoom in much more. All of this playground stuff is considered an obstacle. In the yellow categories, potentially humans. Trees are segmented out, and yeah, that works pretty well. So this is really the kind of environment it's trained on, kind of suburban environments like this. It's not trained so much on big cities. It does an okay job, but that's not really the point right now. Let's try to find some different kind of environments. Here's a beach. Let's see, how do beaches do? Yep, doing a pretty good job of segmenting obstacles there. All that yellow stuff is potentially humans, which it is. There's a bunch of humans there on the beach. So that's pretty good. All the sand is landable. So go and land your drone on the sand. That's probably pretty good. There you go. So that works well. I don't know why beaches are pretty easy. I do have a bunch of beaches in the dataset now, so that might be why. Parking lot. We're too high up. Let's zoom in a bit. So all of the cars are considered obstacles pretty well. Let's go in a bit more. Now this is kind of more coming in for delivery, coming in for landing site. There you go. So cars are doing pretty well. This is kind of a strange image, as you can see, because the contrast is very low. But that doesn't seem to affect the performance of the neural network. there's a lot of that contrast, mess and augmentations in the training data, so it does a pretty good job with that. Fishing village, this one's a cool image. I'm not really sure there's prime delivery sites in there. Yeah, this is pixel mush at this resolution. This one might be kind of useless as a demo. We're finding people, that's not bad. We're avoiding buildings, that's okay. That's really too low res to figure anything out. More beaches, lots of people. Spot people on the beaches, we can avoid them, that's great. People in the water. So it's not trained to know about the sea, so just don't send your drones over the sea with this if you want them to land or if you want to deliver something. But that's just not really the use case that I'm focusing on, so I can train it on the sea a little later. How about this? This is a city scene, like a town, a small town. We're avoiding cars, okay. We're avoiding trees. We're finding humans. Are those humans? Yep, there's a guy there. We're avoiding buildings. That's great. This is a really, really noisy image too, and the neural network does a really good job of abstracting from noise, not caring about noise, because it's trained on this. 2 people on bikes, bunch of trees, bunch of benches. We're avoiding all of this, okay. Avoiding the cars. And there you go, some people there at the restaurant, hanging out. Seems like this was shot kind of in the evening, because there's some lights on here. And you can see just in the quality of the image. I'm not sure this will come through in the stream, but it's super noisy, like super chromatic noise. I guess it's quite low light. But yeah, the neural network does a really good job with that, because I trained it for that, really. It's a lot of the use case for this is in low light, so I want it to work well with low light sensors. Swimming pools, not really our use case. Yeah, this looks like a big mess. And zoom in and figure things out. Yep, there we go. That works too. Avoiding trucks, avoiding cars. Concrete is fine. There's a lot of mess there on the ground that the neural network considers could be humans. It's probably not, but yeah, this is also not really the target. How about this? Yep, there we go. There's some roads, there's some humans, lots and lots of trees, so not much of this area is really landable. But everything that isn't trees is doing okay. Zoom in a bit. We're finding some spots there. Obviously the houses are not safe to land. Bits of garden here are okay. Seems like these people don't have much really garden. This is more like small streets and stuff. Looks like a cool neighborhood actually. I don't know where this is. Anyway, trying to keep this video relatively short. Here's a street. Some houses. Houses are avoided. This guy on the scooter is detected. Cars are avoided. And there we go. I think that's about it. That's about it for this one. Let's see, is there enough resolution in this? Yeah, we're finding something. Streets are okay. Trees are obstacles. There's a house. It's confused about the house here for a second. Ah, there we go. Zoom in and the house is detected. Once again, like a lot of this comes down to the height. These pictures are taken really, really high. Which is not ideal. This just happens to be the set of pictures I have here. Let's look at this. We have some street, some obstacles, some cars, a bunch of trees. It really doesn't like the colors in this image. Or maybe it's just too low res. Here we go. There's some more recognizable features here. There's a drive, that's safe, the trees are avoided, and here's a construction site. That's avoided pretty well. There we go, that's it. This is OpenLander. This is the latest release. Go and put it on a drone, it's super cheap. I explain how to in the repository, what you need to buy. A $100 camera, and you can put this kind of AI capability on your own drone. And that's it. And if you want a full featured version with stereoscopy and all of the good stuff for real commercial use cases, then I have a stereo version which you should definitely contact me about, because it's like this but quite a lot better. So They, all right, thanks for watching.